Ever watched a space movie full of explosions but no sound? No boom at all? Turns out that's not a sound error, it's real. Space is truly silent. But why is that? Let's uncover the unique facts, from the vacuum of space to black hole sounds that'll give you chills. Imagine you're watching a space movie. Spaceship explodes, asteroid shatters, but where's the sound? Just a shaking screen and dramatic music. If that explosion really happened in outer space, you'd be shocked, because even if it's massive, what would you hear? Nothing. Zero. A silence as deep as a cricketless night. So why is that? Aren't explosions supposed to make a loud bang? Let's start with the basics. Sound needs a medium to travel through. That means sound waves have to ride on something like air, water, or solid matter to reach our ears. On Earth, sound gets to us because there's air. But space? It's a vacuum. No air, no particles to carry the sound, so even if there's a massive explosion, the sound can't go anywhere. The result? Total silence. You might think, but the explosion looks huge. Shouldn't there be some sound? Well, here's the deal. Light and sound take totally different paths. Light can travel through vacuum. That's why we can see stars or the sun from Earth. But sound? It's picky. It needs particles to move. So when a star explodes or an asteroid crashes, we can see the flash, but we won't hear the bang. Think of sound like a stadium wave. People jump one by one to make the wave. If the stadium's empty, no wave, right? Same in space. Without particles, like the people in our analogy, sound can't make a wave. An explosion can be massive, but without anything to pass on the vibrations, all you get is silence. Those loud booms in space movies? Just Hollywood spice. So how do scientists know there's an explosion if they can't hear it? They use other tricks, not listening, but watching and measuring. Space explosions usually give off X-rays, gamma rays, and other electromagnetic waves. Telescopes like James Webb or Hubble can detect all that, so even if our ears can't catch it, those tools can hear it in their own way. If you flew into space wearing a spacesuit and shouted, your friend in another suit wouldn't hear a thing unless you touched helmets. Why? Because sound can pass through solids, so if two helmets are touching, your voice can travel through the material. But if not? No chance. That's why astronauts talk through radios, not by yelling. Funny thing, some people think sound can be used for interplanetary communication. Nope. Even radio signals take time to travel between planets. For example, from Mars to Earth, it takes about 5 to 20 minutes depending on their positions. So if you sing on Mars and someone hears it on Earth, that's not your voice directly, but a recording sent via radio waves, not actual sound. The biggest explosion ever recorded in space is called a supernova. That's the death of a massive star, and it releases more energy than billions of suns, but still, no sound. Just a visual explosion and energy waves captured by telescopes. If stars could scream when they died, it'd be like a giant rock concert. But sadly, we can only imagine it. But wait, there's a small exception. In dense regions of space, like gas clouds or near giant planets, there can be enough particles to carry sound. But even then, it's very limited and weak. The sound is more like a soft hiss or ultra-low vibration that only instruments can detect. Not something humans could hear. So don't expect space to sound like Earth. So in short, why is there no sound during explosions in outer space? Because space is a vacuum. No air, no particles to carry sound. You can see the light, you can measure the energy, but your ears? They'll get nothing. That's why space is so eerily silent. But the story's not over. Next up, we'll explore how technology can listen to the sounds of the universe. Stay tuned. So, even though our ears can't hear anything in outer space, there is a way to listen to the silence, using technology. Scientists use special telescopes to capture electromagnetic waves from space objects. These waves can then be turned into artificial sounds, so we can feel what it's like to hear stars, galaxies, even supernova explosions. This process is called sonification. Simply put, sonification is turning data into music. For example, if a telescope catches X-rays from an exploding star, a computer can convert the brightness into musical notes. The brighter it is, the higher the pitch. The result? Space sounds, not actual sound, but a real representation of data. And sometimes it gives you chills. Silence, with a voice. One of the coolest examples of sonification is the sound of a black hole. In 2003, the Chandra telescope recorded pressure waves from a black hole in the Perseus galaxy. The waves were incredibly slow, 57 octaves below middle C, a piano note. But after speeding them up millions of times, we can hear what sounds like a terrifying roar from the darkness. Crazy, right? NASA also made a sonification project from the Andromeda galaxy. The result wasn't just random sounds, it was like a cosmic orchestra. Stars became high notes, black holes made low ones, and everything was blended into a space symphony. The goal isn't just entertainment, it helps scientists discover hidden patterns by listening, not just looking. Even more amazing, sonification helps blind people see space through sound. They can hear star positions, light intensity, or astronomical motion. So the night sky isn't just for those who can see, but also for those who can feel it through sound. This tech makes space exploration more inclusive and meaningful. We can also hear the sounds of planets. Not directly from their surfaces, of course, but from plasma waves and magnetic fields. For example, Voyager picked up radio waves from Jupiter, which, after conversion into audio, sounded like electric hissing mixed with weird echoes. It's like listening to alien radio from another world. Saturn doesn't want to be left out. Radio waves from its rings, when sonified, sound like a mix of ghostly whistles and retro electronic vibes. Spooky and awesome. It's not the sound you'd hear standing there, not that you could, you'd freeze or explode, but sound from the interaction of Saturn's particles and magnetic fields. Space definitely has style. What about the Sun? Turns out the Sun has a song too. NASA scientists recorded vibrations and waves on the Sun's surface and turned them into sound. The result? A deep, consistent droning, like the heartbeat of a giant in the middle of the galaxy, both haunting and calming. It's like the Sun has its own rhythm that's been beating for billions of years. So even if space is physically silent, technology lets us still hear it in creative ways. From star songs to supernova blasts to the Sun's humming. These are new windows into understanding the universe. And this is just the beginning. Who knows, maybe someday we'll stream galaxy music straight from space telescopes. Sorry, Spotify. The bottom line? Sound may not travel in space like it does on Earth, but that doesn't mean the universe is truly silent. We just need the right tools to hear it. With technology, creativity, and a little curiosity, silence becomes a symphony. So next time you gaze at the stars, remember, behind the sparkle, there's a song waiting to be heard. Even though space is silent, technology helps us hear the universe through data and sonification, star explosions, black hole roars, even the sun's song. They can all be felt through artificial sound. The silence out there hides a symphony waiting to be heard. If this kind of content, don't forget to subscribe and turn on notifications so you don't miss other exciting videos. Likes and comments will also help this channel grow even more. Thanks for watching, and see you in the next video.